Before we dive deep into building any machine learning model, we must deeply understand the problem behind it. And in the real world, the problem is bigger than code. It's about people, it's about survival, and in this project of ours, our medium project, it is about food security. So we must deeply understand the problem behind food price fluctuations before attempting to design the machine learning price prediction tool. This second episode of building a price prediction model for food security is just about that. In many countries, especially across Africa, food prices can change wildly within just a few weeks. For instance, 1 month tomatoes can cost 300 Uganda shillings. The next month they can cost 1,000 Uganda shillings. Why? Because food prices are deeply connected to real life events. We're talking of events such as rainfall patterns, transportation costs, fuel prices, pests and diseases, market demand, seasonal harvest cycles, shocks like conflict or pandemics. A typical example being the COVID-19 pandemic that affected global markets, and some countries are still struggling to recover from the market disruptions due to lockdowns. We also have to consider issues like international markets. For instance, for the better part of 2024, you realize that Uganda coffee farmers reaped high profits because of the global surge in supply due to Brazil, which is one of the biggest coffee producers, failing to meet their quotas due to drought. So there are many factors which are involved. When rains fail, harvests shrink. When fuel goes up, transport costs increase. When conflict blocks roads, markets dry up. When it's planting season, supply drops. When it's harvest season, prices fall. Everything is connected. The challenge is this: ordinary citizens feel the impact first, but understand it last, because price change aren't always predictable. And this is where data and artificial intelligence can help. Can we predict food prices before they rise? To solve any problem with machine learning, we need to define it clearly. So here's our problem statement. Food prices fluctuate due to multiple factors such as rainfall, seasonality, transportation costs, and market supply. These fluctuations make planning difficult for consumers, traders, farmers, and humanitarian organizations. Our goal is to build a model that predicts future food prices using historical data. This means we are not guessing, we are not assuming, we are learning from patterns that are hidden inside data. What do we want to know? We want to know what happened before. When did prices rise? What was happening in the environment at that time? How did rainfall affect supply? How did seasons impact availability? And any other questions we will be asking once we start going in deep. Once we understand these patterns and factor them in our design, the model can learn to predict what might happen next. A good project always starts by asking, who does this help? When it comes to food price prediction, the list is long. For instance, farmers need predictions to plan their harvest and decide when to sell. If they know prices will rise next month, they can store their produce instead of rushing to sell early. Traders need predictions to manage stock. Buying too much stock at the wrong time causes losses. Buying too little during shortages means missed opportunities. Families and consumers need predictions to budget better, especially when food takes up most of household expenses. Humanitarian organizations use price forecasts to plan cash transfers, food distributions, and other emergency responses. Governments and policymakers rely on price trends to plan imports, release food reserves, and stabilize markets. So yes, this model might look technical, but the impact is human. That is why understanding this problem is so important. But there is a challenge which cannot be overemphasized, and we will hit it home as we proceed. Data in the real world is never perfect, and projects like this come with constraints we must respect. For example, data quality. Food price data often has missing values, inconsistent formats, and irregular collection intervals. Rainfall data may come from different sources with different units. Sometimes markets stop reporting entirely due to conflict or road closures. Seasonality and complexity. Food prices don't just move randomly. They follow seasonal cycles. But those cycles change depending on region, weather, or even cultural events. There's also access to reliable data. Often, the most important data is hard to obtain or expensive. This means we must work with what we have. There are multiple factors, not no single cause. Prices rise for many reasons at once: rainfall, transport, currency exchange, supply shocks. A model must consider all these influences. Real-world uncertainty. No prediction is perfect. Our goal is not to say the price will be exactly 300 Uganda shillings next month. No. Our goal is to provide direction, like prices are likely to rise, or prices will probably fall. This alone can save people money and save organizations millions. Now that we have a skeleton understanding of the problem, the people it affects, the causes, and the constraints, we are ready to dive into the data itself. We will continue defining the problem deeper as we analyze different data sets and telling stories about them. In the next episode, we briefly explain the machine learning life cycle before we start exploring the messy real-world datasets behind our model. Let's build something meaningful together.